previous class we studied Z transform properties. Today's class is how to find inverse Z transform using different methods. So inverse Z transform using different methods. Using residue method. This is also called as a contour integration. Contour integration. Second is power series. Power series, there is another method, long division. Long division. Third one, partial fraction. Partial fraction method. So these three are there in the syllabus and they are helpful to find the inverse Z transform. So each method I will solve some problems. When I am solving the problem, you will understand the method, how it can be implemented. This is already studied in mathematics. This is a long division concept, you are already know normal division only. But when I am solving, you will understand what is power series. Partial fractions already done in Laplace transform or even in mathematics also is studied. So these are all almost known methods only, but how we can apply them to find the inverse Z transform. So let me take one example. X of Z is one by 1 minus 2 Z inverse. Mod Z greater than 2. Find X of n using residue method. If they mention this method in the exam, you have to use this only, otherwise any method of your choice. This problem is very simple. Greater than 2 means right side sequence. So what is the answer? X of n is 2 power n u of n is the answer. We know this answer already. But using this method, how to find? So what is X of n formula? Inverse Z transform? 1 by 2 pi j closed integral X of z z power n minus 1 dz. This is the formula for X of n. Now in this integral 1 by 2 pi j integral X of z is 1 by 1 minus 2 z inverse z power n minus 1 dz. So we can simplify this further. Multiply with z, multiply with z, divide with z. So what is numerator? Z power n by z minus 2 dz. Okay. So here if you see the problem, mod z greater than 2, it is having a pole at z equal to 2. Mod z greater than, this is ROC. So there are two cases. Case 1, for n greater than or equal to 0, for n greater than or equal to 0 means positive value of n, so it has a zeros, it has one pole at z equal to 2, that pole is inside this contour. A contour is mod z greater than 2 inside, so this is the valid pole. So that answer x of n is equal to 1 by 2 pi j f of z dz. This is f of z. F of z dz is equal to residues of f of z at z equal to 2. At z equal to 2. So this is nothing but limit z tends to 2, z minus 2 into fz. Fz is z power n by z minus 2. So this cancel, z tends to 2, you get to 2 power n u of n is the answer. 2 power n u of n. For greater than 2, so right side sequence, 2 power n u of n, got it. But we have to ensure nothing is there left side. How to see that? For case 2, for n less than 0, let n equal to minus 1. If n equal to minus 1, what is x of n is? 1 by 2 pi j integral 1 by, here z is minus 1, it will come down. So z into z minus 2 dz. Now it has a pole at z equal to 0, it has a pole at z equal to 2. Z equal to 0, z equal to 2, both are inside the contour. So we need to consider both. So that answer is what? Residues of f of z at z equal to 0 plus residues of f of z at z equal to 2. One is at z equal to 0, other is at z equal to 2. Both we have to consider. Residues of f of z at z equal to 0, residues of f of z at z equal to 2. This is limit z tends to 0. So z cancel, otherwise you can write z into 1 by z into z minus 2 plus limit z tends to 2, z minus 2, 1 by z into z minus 2. So this cancel, this cancel, simplify, you get a 0 answer. You will get a 0 answer. Similarly, for n equal to minus 2, what is x of n? 1 by 2 pi j closed integral. Here z square will come, z minus 2 dz, which is equal to residues of f of z at z equal to 0, z equal to 0 plus residues of f of z at z equal to 2. But here z equal to 0, multiple poles are there. So here formula is different. Limit z tends to 0, d by dz of this z square will cancel, you get 1 by z minus 2. Plus limit z tends to 2, z minus 2 will cancel, 1 by z square. That's all. So simplify this one. Again answer is 0. Again answer is 0. So for n equal to minus 1 0, n equal to minus 2 0, similarly n equal to minus 3 also 0. So negative values answer 0. For positive side only we are getting, which is 2 power n u of n. So finally we got same answer because we know the answer already. Using this method also same answer we are getting. So this is how we can apply contour integration method or residue method. We will see next problem. X of z equal to 1 by 1 minus 1.5 z inverse plus 0.5 z power minus 2 mod z greater than 1. So find x of n using residue method. So you can multiply with z power 2. So you will get z power 2 by z square minus 1.5 z 0.5. Okay, so we want x of n. This can be factorized, z square by z minus 1 into z minus 0.5. Z minus 1 into z minus 0.5. So x of n equal to 1 by 2 pi j. X of z is z square by z minus 1 into z minus 0.5 z to the power of n minus 1 dz. So if you simplify, 1 by 2 pi j integral, here z power n plus 1, z power n plus 1 by z minus 1 z minus 0.5. So this is like a f of z, f of z. This is equal to what? It has pole at z equal to 1, it has pole at z equal to 0.5. And this 1 and 0.5 are inside the contour. Here mod z greater than 1. So inside the contour of 1. So these two valid poles both we consider. So therefore it is nothing but residues of f of z at z equal to 1 plus residues of f of z at z equal to 0.5. So this is nothing but limit z tends to 1, z minus 1, that will be cancelled anyway, z power n plus 1 by z minus 0.5 plus limit z tends to 0.5. So this will cancel, z power n plus 1 by z minus 1. So this you simplify carefully. This answer is 2 minus 1 by to the power of n. N greater than or equal to 0. So this is the answer. This is the answer. Here we have two simple poles. So follow this procedure, you get the answer. Next, power series expansion. So problem is x of z equal to 1 plus z power minus 1 by 1 minus 1 by 3 z inverse. Find x of n for mod z greater than 1 by 3. Second case, mod z less than 1 by 3. Now using power series is simple. When mod z greater than 1 by 3 means it is a right side sequence. For any right side sequence you divide like this. 1 minus 1 by 3 z inverse divide 1 plus z inverse. Just power series is nothing but long division. So to get 1 minus 1 by 3 z inverse. This is plus minus, this cancel. 1 by 3 plus 1. So 4 by 3 z inverse. Then to get this one, 4 by 3 z inverse. This into 1 is same. Next to minus 4 by 9 z power minus 2. This is plus, this is minus, cancel. So 4 by 9 z power minus 2. Again plus 4 by 9 z power minus 2. 4 by 9 z power minus 2. Then minus 4 by 9 into 3. 27 z power minus 3. So minus plus, this cancel. plus 4 by 27 z power minus 3. So like that you continue. Like that you continue. Negative powers of z means right side sequence. So you can write x of n now. Now you can write 1 comma 4 by 3, 4 by 9, 4 by 27, like that you can write. This is the answer. So we are following this kind of division because it is a greater than 1 by 3. If it is less than 1 by 3, this order only you have to change. Everything same, only order change. So minus 1 by 3 z inverse plus 1. Here z inverse plus 1. That is only the change. So just change the order of the polynomial and continue the division. So to divide here 3 minus 3. So z inverse minus 3 plus minus cancel 3 plus 1 4. To get 4 here minus 12z. 3 4 ja 4 minus minus, so you get 4, then minus 12z plus minus cancel 12z. Okay, now 36 minus 36 z square. This into this, so 12z minus 36 z square plus minus cancel 36 z square. Like that you continue. But here it is positive powers of z. So how we can write x of n? You start, it's a left side sequence. Start here with minus 3, minus 12, minus 36. Like that it will go. So this is answer. It's a left side sequence. Left side sequence always positive powers. Right side sequence always negative powers of z. If you divide as it is, you get a negative powers of z. If you change the order and divide, again you get a positive power. Here less than 1 by 3 means left side sequence. Change the order, divide and get the answer. Greater than 1 by 3 right side sequence, divide as it is, you get a negative powers of z. Sequence will be right side. That is the main concept of power series expansion. It involves normal division, but carefully divide. Accordingly you can write. So this is another special problem. Given x of z is e power z with ROC, all z except mod z equal to 1. Find x of n. We are not solving using power series or any method, it's a special problem. We know that e power x is this. N equal to 0 to infinite, x of n by factorial n. If it is e power x is this, e power z is this. X replaced with z. Now 0 to infinite change it to 0 to minus infinite. N replaced with minus n. Here minus n factorial. Now 0 to minus infinite. 0 to minus infinite I am changing minus infinite to plus infinite. 1 by minus n factorial. Z power minus n. Extra I have taken u of minus n. U of minus n I included, but limits minus infinite to plus infinite. So 0 to minus infinite it is there. and other side this value is 0. Right side its value is 0, left side it is there. So in this range this value is 1, other range this value is 0. So when I included u of minus n, I can take like this. But how this is looking like a Z transform formula, na? So therefore x of z. So if you compare with x of z formula, this must be x of n. So x of n equal to 1 by minus n factorial u of minus n. So it is one special problem. Like this only we can solve. So this is another problem. X of z is sin z. Find x of n. But this sin z is z minus z power 3 by 3 factorial plus z power 5 by 5 factorial minus z power 7 by 7 factorial. Minus plus minus changing. 3, 5, 7, 9. Denominator factorials. But here expressed in positive powers of z. Okay. So positive power of z means left side sequence. Here started with the z power. So first value will be 0. Then 1. Z power 2 not there. 0. Here 3 factorial. 3, 4. 4 is missing. 0. 1 by 5 factorial. Again 0. Minus 1 by 7 factorial like that. So left side sequence now start here and go like this. So like this we can find x of n. Next method is partial fraction method. How to find x of n using partial fraction method. This is one of the simple method. So this is x of z given ROC between 1 and 2. Find x of n using partial fraction method. So here z power minus 2. So what is the best way is multiply with z power. Here denominator power is minus 3. So z power 3 by z power 3. Multiply, divide with z power 3. So it is z power 3, z power 2 plus z by z minus 1 by 2, z minus 2, z minus 1. So this is x of z. Now this power is 3, this power is also 3. So this is another technique, xz by z. Then z square minus z plus 1 by z minus of z minus 2, z minus 1. So this power should be more than numerator power. Then only we can use partial fractions. So this is nothing but a by z minus 1 by 2 plus b by z minus 2 plus c by z minus 1. So we can find easily a value. So what is the technique? This term cancel. Simplify z square minus z plus 1 by z minus 2, z minus 1 at z equal to 1 by 2. So just to simplify, you will get to a answer 1. You will get a answer 1. Similarly, you can try. B answer is 2, C answer is minus 2. So with the help of A, B, C, so what is x z by x z? Straight away x z. A is 1 na? So the Z will go there. So it is 1 by 1 minus of Z inverse. Then B value is 2. 2 by 1 minus 2 Z inverse. Then C value minus 2. So minus 2 by 1 minus Z inverse. This is X of Z. What we want? X of N. So what is inverse of this? Is taking ROC greater than 1. Greater than 1. So if it is ROC greater than half, right side. Greater than half, right side. So he is taking greater than 1, that itself greater than half, so right side. Therefore this answer is 1 by 2 to the power of n, u of n. Next. There mod z less than 2. Less than 2. So left side sequence. Minus 2 to the power of n, u of minus n minus 1. Next here 1 is there. Greater than 1, right side. So 2 u of n. This is answer. That's all. So like this we can find the x of n. Next problem, x of z is 1 by 1 minus 1.5 z inverse plus 0.5 z power minus 2. Here find x of n. Find x of n if mod z greater than 1. Second case, mod z less than 0.5. Third case, .5 so between 0.5 and 1. So for 3 cases, how to find the x of n? So again here z power minus 2 na? So multiply with z power 2, divide with z power 2. So therefore x of z equal to z square by z square minus 1.5 z plus 0.5. Now x of z by z is z by, the second order can be factorized. We get z minus 1 into z minus 0.5. 0.5 into 1, 0.5. So you will get same thing. Now denominator power is more than numerator. This is a by z minus 1 plus b by z minus 0.5. So you can find a and b easily, just using previous method. So how do you find a? This cancel. Z by z minus 0.5, simplify at z equal to 1. And this answer is, you will get to 2. Similarly, find the b value, you will get minus 1. So therefore x of z, this z will come here. So that is 2 by 1 minus z inverse minus 1 by 1 minus 0.5 z inverse. Now we have to find x of n. first case is mod z greater than 1. Greater than 1, greater than 0.5. So both are right side. Right side means this is 2 u of n. This is also right side, minus 0.5 to the power of n u of right side na anyway. So u of n. 0.5 to the power of n u of n. This minus, this minus. So this is first case. What is second case? Second case, x of n. What is given here? Less than 0.5. So less than 1, the requirement is less than 1. 0.5 itself less than 1. So this is left side. And this is also left side. So left side means 2 minus 2 u of minus n minus 1. Then this is also left side, already here minus is there. So minus plus, then 0.5 to the power of n u of minus n minus 1. So that is second answer. That's all. Then third one, between 0.5 and 1, mod z greater than 0.5. Here greater than 1, so greater than 0.5. Greater than 0.5. It should be greater. If I take 0.6, 0.6 is here is 1, so greater than 1 we want. But what is coming? Less than. So this is left side. So x of n equal to minus 2 u of minus n minus 1. Then here less than 1, maybe 0.6, but 0.6 greater than 0.5, so that is right side. That is right side. So minus 0.5 to the power of n u of n. So this is right side, this is left side. So this is the best model to understand if it is greater than 1, less than 0.5, if it is in between, how to find x of n. First case both right, second case both left, here one left, one right. Depending on the ROC, you should know how to write. Another problem, x of z is 1 by 1 plus z inverse 1 minus z inverse square. Z inverse square. So here denominator power is 3. So multiply with z power 3, divide with z power 3. So you get x z by z. Straight away I am writing. You will get z square by z plus 1. Z minus 1 square. This is a by z plus 1, b by z minus 1, c by z minus 1 square. Here square is there, z minus 1 term will come, z minus 1 square also will come. So with z minus 1 cube, z minus 1, z minus 1 square, z minus 1 cube, like that you have to write. So A is straightforward, z square by z minus 1 square at z equal to minus 1. So simplify, A answer is 1 by 4. Whereas B answer, this term totally cancel. D by dz of z square by z plus 1 at z equal to 1. at z equal to 1. So this is B is 3 by 4. C straightforward. This cancel. What is remaining? Z square by z plus 1. Simplify at z equal to 1. So this answer is 1 by 2. Answer is 1 by 2. So therefore, x of z equal to 1 by 4 by 1 plus z inverse, this one. B is 3 by 4. 3 by 4 by 1 minus z inverse. C is 1 by 2 by 1 minus z inverse square. Now we have to find x of n. ROC given greater than 1. ROC mod z greater than 1. So what is x of n? 1 by 4 minus 1 to the power of n u of n plus 3 by 4 u of n plus 1 by 2 n u of n. This n u of n z transform already discussed, so we'll get this. This is the answer. Mod z greater than 1. So here greater than 1. All are right side, 3 terms. Like this we can. X of z is z power 3 minus 10z square minus 4z plus 4 by 2z square minus 2z minus 4. ROC mod z less than 1. Here already positive powers, numerator power is greater than denominator. You can't use partial fractions. You can't take xz by z also, still powers are equal, so not allowed. So first to divide. 2z square minus 2z minus 4 z power 3 minus 10z square plus 4. So here we want z power 3. So it is z by 2. Z power 3. 2 cancel, minus z square, then minus z, plus minus cancel. Here it is minus 9z square minus 3z plus 4. Next term you will get minus 4.5 or minus 9 by 2. So minus z square plus 9z plus 18 minus 11z minus 14. So finally what is x of z? Z by 2 minus 4.5 minus 5.5z plus 7 by z plus 1 into z minus 2. Here 2 common, factorize, you get this. 11 by 2 5.5, 14 by 2 7, 2 common, and remaining factorize, you get this. So using partial fractions separately you do it, and finally x of z is 0.5z minus 4.5 0.5 Z inverse by 1 plus Z inverse minus 6 Z inverse by 1 minus 2 Z inverse. So x of n equal to 0.5 delta n plus 1 minus 4.5 delta of n minus 0.5 minus 1 to the power of n minus 1 u of minus n plus 6 2 power n minus 1 u of minus n. Just to see this, minus of minus 1 to the power of n minus n minus 1 is 1 by 1 plus Z inverse. Minus 1 to the power of n u of minus n minus 1 1 by 1 plus Z inverse. Then minus of minus 1 to the power of n minus 1, in place of n I am writing n minus 1 u of minus n minus 1 minus 1. Because of n plus n, in place of n minus 1, so z minus 1 by 1 plus z inverse. This is nothing but minus 1 to the power of n minus 1 u of minus n. So this is z inverse by 1 plus z inverse. So this term of z inverse by 1 plus z inverse minus 1 to the power of n minus 1 u of minus n. So here mod z less than 1. So because mod z less than 1, this will be 6 2 power, basically 2 power n u of minus n minus 1. So in place of n you write n minus 1. This will be n minus 1, this will become minus n. So this answer is minus n. This is the answer. So depending on ROC you have to write. So like this we find the inverse Z transform using these three methods. So first method is residue method, second one is power series expansion, third one is partial fractions. So be familiar with these three, how to find inverse Z transform. So this topic is over. Next class will continue new topic.